All right. We are live for day 2 of Admin and Code. Again, an hour early. So I'm going to be back solving through 2015. I did start refactoring yesterday's a little bit. There's one thing I found in the forums. I was thinking about, it was on my mind yesterday, but I couldn't remember. So with this mod, with the negative mod, you can use math.floor mod. And if you're to do like negative 18, mod 100, that will give you 82. So that will give you a normalized mod. Hey, Alka. Hey, good to see you. It's been a year. Were you streaming last night? But I'm gonna rewrite these with floor mods. So I don't have to do my weird normalize by adding 10,000. Actually, can I just do math? Yeah. Um, all right, all right. Yeah, good to see you too. I hope your stream went well. So this is all gonna be math.floor mod. Next 100. And we don't need to do our own normalization. And we might as well be consistent here. Math.floor mod. Next 100. Good to hear. I feel like Advent Code has been quieter this year as far as streamers. Or maybe it's just the times I look, but I didn't see very many people online. I didn't see you online. Maybe it's my tag filters or something. Um, Day one was all right, but I was bracing myself for like a one-liner typing contest. So I had a little bit of hubris and I slowed myself down a bit, not testing properly. Mm. Oh yes, yeah, get that tag in there for sure. And I should also search without the tags on. So 2015. Last night I didn't finish 4. 4 is just the same as part 2 is just the same as part 1, but I need to optimize a little bit. Um, so here we're looking for like an MD5 sum that starts with a bunch of leading zeros. And basically we're doing like a brute force search because you can't really, reverse a hash. So every little bit matters. This take 5 is making a new string. I think we just want to use starts with. So it starts with, and then 1, 2, 3, 4, 5. There we go. If this doesn't work, I can also just not convert things into a string, keep the array of bytes. But if I do that, this is like 2.5 bytes. I don't want to have to split a byte in half. That'd be a little bit annoying. Okay, it's a little bit faster. Let's see if that's good enough for part 2. We'll do starts with, and 1, 2, 3, 4, 5, 6. Give it a few seconds. Alka, do you have plans for days 13 through 25? Are you going to do anything like Abna code related? I guess maybe you don't necessarily plan your whole stream around Abna code. That's just me. Okay, this evaluated 25 seconds. Still slower than I'd like. But at least it didn't time out. I've had an issue lately with my worksheets not showing the input after it's evaluated, and I don't know what that's about. There it is. Do I work in NYC? No, not anymore. Um, I live in Maine now. So I lived in NYC during the pandemic. And I got out just before they started locking it down. And I haven't been back since. So these days I work remotely. 1038-736. Oh, there it is. I'm gonna keep this commented out because I don't want it running in the background. Why do you ask? You're not an NYC person, are you? Yeah, I think it will ramp up fast. Um, I don't mind that. The last half is the more fun half usually. And honestly, sometimes like the first 5 days are just like speed typing contests. So it's nice to start with a problem that takes some time, you know? You're still there. So you stayed there through the pandemic? You weren't one of the people who run off? I always thought I'd go back, but I kind of settled in Maine and like it here. I'd still like to visit more often. But I feel like everyone who lives in NYC loves it and hates it. Like no one wants to leave, but everyone wants to leave, you know? Alka after AOC made a fishing game chatbot with a database and started to make an API with socket and partial overlay system. Oh damn. Wait, after AOC, how late were you up? Oh, the return to office policy. Yeah. That's made it harder to find gigs lately. It's harder to find remote gigs. And I do contracts, and I know everyone wants you to do like hybrid on site. Maybe if they flew me down to NYC 3 days a week, I'd take them up on it. But nope, nope. Do you think the RTO is just a cover for laying people off? Being up late is normal. Yeah. Yeah, I'm all prepared to be up late every night this month. Day 12 or not. I think what I want to do on day 13, have you heard of Cinecore? It's like a puzzle made by Eric Wastel before Advent Code. And it's another one of these like reverse engineering bytecode things. And those Advent Code puzzles are really fun. Yeah, he mentioned it a couple years ago, and it's been on my list. Like, if you really like 2019 int code, this would be right up that alley. So I'm thinking to extend the Eric Wastel season, I'm gonna do Cinecore on day 13, and we'll just do that how many ever days until it's done. But it'd be cool if other people did it too. So I'm spreading the word, trying to get everyone to do Cinecore day 13. Or that's what I think I'm doing. I just had this idea. Okay, day 6 of 2015. Let's think about this. Your neighbors keep defeating you in the holiday house decorating contest. You decide to deploy 1 million lights in a 1,000 by 1,000 grid. Okay. Santa has mailed instructions on how to display the ideal lighting configuration. Lights are all numbered. Um, the lights at each corner are 00. Okay, they're numbered by the coordinates, basically. The instructions include whether to turn on, off, or toggle various inclusive ranges given as coordinate pairs. Okay, so we're toggling whole ranges of lights. Each coordinate pair represents opposite corners of a rectangle. This is reminding me of the cube from 2021, the light cubes. It's just that problem, but in 2 dimensions. So I think the difficulty in part 2 here will be scaling it properly. Do I have a link to the Cinecore? Yeah, let me see about that. Um, Cinecore. Um, Here's a link. So it's basically just mirrors now. The site is down, but people have put mirrors on GitHub. Yeah, but if you look here, um, basically the challenge is this binary file, right? And then you get this document, and that's it. You go from there and you start decompiling, reverse engineering whatever that binary is. Um, and they give you like the machine code to help decipher it. And apparently there are like 8 stages. There's like 8 answers you can pull out of this. So that'd be fun to dig into. I don't know how long it would take. I- I'm sure. Oh, Boylan. Hey, hey. Yeah, no problem. Um, I did see you finish it. So I enjoyed your stream. Thanks for being up there. Good luck to you too. Hmm. Um, my younger brother, was thinking of doing maybe a little bit of advent code this year. He's not a coder per se, but he started learning Godot. So I've mentioned to him that hey, there's someone here doing it in GD script. You could do that too. Okay, so back to day 6 here. We have a grid of lights. They're all numbered, and we have instructions to turn to toggle whole ranges of lights at a time. Um, each coordinate pair represents opposite corners of a rectangle. Okay. 0, 0. Okay, I have a model for this that I've written already for these kind of ranges, areas, I call them. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent you in order, and how to extract your answer. After following the instructions, how many lights are lit? Okay. Yeah, yeah, definitely have a look, Alka. I'll probably keep mentioning that in the next few days. I want to see if other people are interested in doing it. Um, okay, we're gonna import AOC dot point and area. GD script is a great way to start learning how to code due to simplicity. Oh, you got your kids to pick it up. Cool, cool. Yeah, you enjoy day 2 too. Um, what are we doing here? So we have our input. Can you see what our input looks like? Instructions. So one of 3 possible instructions. So we could parse the instructions separately, um, or we could just apply them. We could apply them to our main area. So let me make this bigger here, this text. So we have our grid. Grid equals area. Oh, um, I have other ways to create an area. Let me see. It's been a while since I've used this library. So area, we have an X range and a Y range. Okay, so 0 to 99 in each. 0 to 999 and 0 to 999. And I guess initially they all start off. We could do a map of all the coordinates. So yeah, they all start off. Hmm. Let's take a look at that input again. Okay, so we'll take our input. Um, and I suppose we're gonna fold. How many of them are there? Let's do input.size. 300. Yeah, I don't think we need to use a special data type here. We can just do a map of all of these. I hope that's fine. We might flip up to 1,000,000 lights. I'm wondering if we need to be more efficient, but we'll start by doing it the stupid way, and then we can improve it later. A stupid way is always, less bug prone. So input that fold left. Let's just make a map, a mutable maps import collection dot mutable dot map val lights equals map empty of point through boolean. I guess it's just a set of lights that are on. Yeah. So this seems to be a set. Uh, set dot empty of point. So I guess we're using a mutable set. And then we're going to do input dot for each case. So we have turn on. And now we can create an area from 2 points, right? We have other constructors. Um, area dot bounding from 2 points. Cool. Uh, so we'll call this we'll just call him x1. So x1, x2 through or y1 through x2, y2. And we'll do similar matches. So it's either turn on, turn off, or toggle. Yeah, before I continue, let's just talk about the more clever ways to do this. So like we could start basically backwards, right? And figure out what the last action was done to a particular square to determine whether it's light or not. And we just do that for every square in the grid, right? All 1,000,000 of them. There are 1,000,000 squares in this grid. I'm thinking this might not be performant enough. Hmm. And then the toggles make things a little bit more complicated. So this isn't just like taking a union of sets. This should probably be a fold of some sort, but we'll continue to write it a stupid way. We'll just take 10 just to like test things out. Okay. So let's do this val area. I'm just gonna separate the parsing out into a separate step. So we'll do an enum. Enum directions. Hmm. Okay. So we have our instructions. So case on, and then we have an area. And then we have case off, area, and then toggle a area. And we're going to do an input dot collect, and at least parse that as a separate step. So we're going to do area dot bounding, and then point from x1 dot to int to int, and then x2 or y1 dot to int. And then similarly with the second one. So we have x2 and y2 dot to int. And we can just create this way, copy paste all that. So we have toggle and we have off. Okay, so we've parsed our instructions. Oh, and we need to import that from the instructions. Val instructions. Okay, so we've got our list of instructions. And we could try this. We'll try this mutable approach just to see if maybe it's performant enough, but I doubt it. So, okay, we've got our lights. Instructions dot for each. Okay, so if it's on, in some area, then a dot points iterator dot for each lights plus equals that point. We're just gonna make that a one liner here. P lights plus equals. Okay, and then we have our off case. And we have our toggle case. And let me see, to toggle a light. if lights contains that point, so let me do it this way. So P, so we have a point. If lights dot contains P, then lights minus equals P, else lights plus equals P. All right. I still think I'm gonna let that run, see how long it takes to run through 10 instructions. And then we'll look at lights.size, and that'll be our ends one. I still think we should keep track of like ranges of lights that are on, like areas of lights, rather than like the individual, having a set with up to 1 million members probably isn't what we want. Um, but this can be useful for testing. Okay, 603,000 for the first 10. And that ran in 2.25 seconds. And if we just let the whole thing run, let's see. I mean, maybe like the ranges are reasonably sized. I mean, this one here is like 100 by 100. So let's say there's 1,000 flips, 1,000 times 300. We're doing, maybe up to 1 million flips. We have a gigahertz processor. Okay, great. Brute forcing it works. We don't have to be clever. 951,616. Oh, that is too high. So we have some sort of bug. 616. But hey, at least we don't have to worry about performance issues. Okay. Let's figure out where this bug might be. We should look at example data. So I'm going to turn this off for a bit. Let's say, geez, so this is like an execute that, hey, Ice Cold Witch, welcome, welcome. Hmm. There's not really great like example data here. Okay, well, we can write our own test, I suppose. Okay, we'll leave that there as is. And maybe we just write a new test file. So day 06, 2015. Okay. So let's say we turn on, um, I don't know, just a small square in the top right. So 0, through 2020. Let's make a rounder number. So 10, 10. Okay. And wait, is that inclusive? Maybe that's where I'm off. So 0, through 2 is 9 by 9 square. Okay, and that is how I think I'm interpreting it. We'll see. Um, if we just ran that, we should get 100 lights, right? And wait, 121. Okay, so we're not, it's 11 by 11. I see. Hmm. Okay, so my area is off. So when I do a bounding, what we do is range p dot x to q dot x. So that's inclusive for both the x's. Wait, so 0 through 10. Oh, right. Yeah, 0 through 10 would totally be 11 by 11. That's correct. Okay, so back to the example. Let's make this 9, 9. And then let's turn off 25 of them. So let's say 0, 0, 3, 4, 4. Okay, let that run again. And then that should come up to 75, right? And if we do a toggle, let's say 5, 5 through 14, 14. So this should turn on like 75 lights that are outside and turn off 25. So we had 75, we double to 150. It should be 125. Okay, we'll let that update. I don't know if it's updating properly. I'll give it a second. Um, wait, 100. 100. Does that make sense? That doesn't make sense. Okay, so if a light contains P, then we subtract that P. Else we add that P to the element, that point to the set. Okay, well, let's backtrack just one step. So let's delete this, and this should be 75. Wait, right now it's 100? No, that's from earlier. Oh, it is 100 right now. That's odd. Okay, so we're not subtracting properly then, because this should have turned off 25. Um, let's make sure we're using this set properly. So, oops. Set that val s equals set. Let's say empty int. So s plus equals 1, right? And then s minus equals 1. Yeah, that's correct. Lights minus equals p if it contains light. Otherwise, lights plus equals p. In this case, oh wait, our off is adding. We need to subtract it. There we go. It's not a toggle, that's the issue. Great. Well, let's put that back in there. And this should be 125. And that's probably the issue that we had with the main example too. Yeah. Wait, no, not 75. It should be 125. Because of the toggle. I think it's just slow to reload my answers here. No, okay. It seems not to have done anything at all. Okay, well, let's look at what's in the set then. I have a way to print. So we can do area 0 to 14, 0 to 14 dot draw. And basically, if lights is on at that point, then we'll draw this character. Otherwise, we'll just draw a period. Let's see what lights are on. Okay. That's not very legible from here. I'll copy worksheet output. Okay, this is what that looks like. Yeah, and it looks like the toggle is not doing anything. Oops. Okay, well, why would the toggle not be doing anything? We take the area, we iterate through all of its points. What is our area? Let's read all of our instructions. Set instructions for each print line. Make sure we just parse them properly. So for each point, if the light contains that point, then we subtract it from that set. Otherwise, we add that to the set. I don't see why that should be an issue. We don't want to install that. Okay, so we have an on, we have an off. Oh, we are not even parsing the toggle. Interesting. It's clearly right here. Let's look at what our input looks like. There's a toggle. Oh, wait, it's skipping it because I have turn toggle. It's just toggle. Okay, so it's just not parsing altogether. That's what happens when you use collect instead of map. Let's make that map because they should all pass. You want any errors to actually show up. Okay, now it's 125. Good, 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 good. Now we can do this on the real problem. Let's take out some of this test code. Let that run for a few seconds. Should still be like under 20 seconds, even though we're just kind of brute forcing it. 13 seconds, and we get 377,891. Okay, part two. Um, you just finished implementing your winning light pattern when you realize you mistranslated Santa's message from ancient Nordic Elvish. Okay. The light grid you bought actually has individual brightness controls. Each light can have a brightness of 0 or more, and the lights all start at 0. So turn on actually means that you should increase the brightness. Turn off means you should decrease the brightness. Toggle means you should increase the brightness of those lights by 2. Oh, okay. Hey, Ian Beckett, welcome. Good luck tonight. I saw your part 1 code. Thanks for sharing that. Yeah, I think I had a lot of hubris last night, kind of going in without testing. I wasn't ready to be debugging edge cases on day 1 of having the code. So we have a part 2. I think we're just gonna do the same approach with a mutable map instead. Don't tell my colleagues I'm using mutable collections. That is a heresy. So import collections.mutable.map our lights2 equals map.empty. I guess this is from point to. Oh, interestingly, now we're just counting like appearances in areas. Turn on means increase by 1. Turn off means decrease by 1. We could do this the opposite way. Like for every point, every possible point, we just count how many instructions match that range. I might like to do that. I've already got momentum here, so I'm just go ahead and do this the mutable way. But if this works, or if it doesn't work, I'll just switch over. So we have a point to an int with default value of 0. And we have a negative brightness to a minimum of 0. Okay, good to know. Oh, so we can't just look for everything that overlaps and subtract them all. The ordering still does matter. Okay, instructions not for each. So we're gonna do the same kind of thing. Case on. Oops. I kind of wish it just autocomplete the match for me. We'll just copy paste this. And I need to make my text bigger, don't I? Okay. So here, the on is pretty straightforward. It's always going to be plus equals 1. And here, the off, it depends. If it's 0, then we can't do anything. So if this is lights 2. If lights 2, well, we need to take our points. So if lights 2 on P equals 0, or is greater than 0. Yeah, we'll do it that way. Then lights 2 minus equals 1. And toggle means increase by 2, always. So for each lights 2 plus equals 2. lights 2 at that point. Okay. That should at least compile. Val adds 2 equals, and then what? The total brightness? Lights 2 dot values dot sum. Okay. Lights 2. Fix some typos here. And if this doesn't work this way, I still kind of like the idea of taking each light and then just going through all of its state changes as these light switches go. Um, hey, the timeout was reached. Okay, let's do this a different way then. So we're gonna take our grid. That's our entire area. That points iterator. And we're gonna map over each of these. That map. And for each of these, we'll run all the instructions. Let's see. We'll make a function called like a switch. So given a point P, now we'll just inline everything. So for each point, we're just going to run that all the way through. So instructions dot fold, and we're going to start at 0. Case. Oh, wait, we want to fold left. Whoops, I don't know what that is. Okay. Okay, so we have our brightness. So we'll call that B. And we have our instruction. So if it's on A, we'll do like if A dot contains P, then we do B plus 1. Brightness increases by 1. And then case off, if again, if the point contains, and let's do an AND condition, and B is greater than 0, then B minus 1. Hey, Michael PC Gamer, good to see ya. You recorded last night, and we'll stream tonight. Okay, good luck with your stream tonight. Okay, this is pretty straightforward. I should have maybe done this approach for part 1. And then we have a toggle. So case toggle in that area. So if the area contains our point P, then it's always just going to be brightness plus 2. Great, and that gives you all the brightness values. And we just get the sum of all those. Val adds 2. That dot sum. Okay, and I'm just going to go ahead and comment out part 1. Oh, it doesn't like something about this. What's wrong? Oh, we had a match error? Oh, yes. In any other case, case B and any other instruction that doesn't match properly, then we just return B. Okay. All right. So for each of the million lights, we run through all 300 instructions and follow how its value changes. And the reason I'm not just counting all the ons and offs is because that 0 does matter there. It does depend on the context. So it does have to be done in order. Hey, and we have an answer. 14110788. Hey, there we go. Well, that problem took me a minute, so I probably won't do any more before we start day 2 of 2025. Maybe I'll take a quick peek at 7. I could do a little refactor here. I could take the same approach for part 1 and see what that looks like, because I do like that I'm not using a mutable, map anymore. Thanks. Oh, yeah, I do like how this cleans up, right? It's pretty compact. And I know even if you don't write Scala, this is pretty understandable, right? So let's try this with a. So what happened in part 1? Just on, off, and toggle. Okay, so we'll basically copy this. Now, when it's on, I don't know, I guess everything starts off, so we can start with false. Yeah, we can keep it at 0. So this just turns it into 1. And then off turns it into 0. So if b equals 0, then 1, else 0. That's toggle. And I don't think this here matters anymore. Otherwise, b just stays the same. Okay, and then since it's just ones, we can still just sum them, because everything becomes either 1 or 0. Dot sum. Okay, I like that better than flipping bits in a set. We'll give that a second to run. Oh, wait, did it run? And the sum is 0? I'm not sure if it ran or not. Oh, there we go. And just to double check, that is still the correct answer. 377891. Okay, I like that much better. There's a bit of boilerplate, but I like the final code that it gives us. This is pretty easy to understand. We can change this. What we can do at the end is count any point just as that Boolean. So we can just count identity. So this can start false, and this will always be true, false, and then this can just be not B. And then that should give the same answer. And that feels pretty satisfying. That's a good warm up. All right. Well, 4 minutes to go. Which of you are playing the stream tonight? Michael PC Gamer, Alka, and Voilens. I think all of you are going to be streaming. So good luck. I don't know if you've already gone live or not. Oh, we'll leave this running. I need to make sure my thing is ready to download. Okay, AOC input 2025 day 2. Whoops, not yet. We're gonna sleep for however long. 3 minutes and 5 seconds. Sleep 3 minutes and yeah, 3 minutes is fine. Whoop, whoop, whoop. Alrighty. Dev everywhere. Welcome, welcome. What are we building? We're not building anything tonight. We're doing Avena code. So we are solving puzzles. And the puzzle is about to drop any minute now. So puzzles come out every night at midnight. Midnight Eastern time. All right. Good luck, Michael. Oh no. Day 2, 2025. Wait, do I not have? There we go. Ah. Alrighty. Oh, I see like 3 different people just started Advent of Code. Vasher, Rascal 2, and Coding Garden. So, plenty of streamers doing it. A lot more lively tonight. Good luck to you too, Ice Cold Witch. And there are plenty of people not active this year. All right, 10 seconds. Good luck, everyone. See you on the other side. Gift shop. Okay, you get inside and take the elevator to its only other stop, the gift shop. Yada yada. I'm gonna skip over that just a little bit. One of the younger elves is playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Okay. You need to identify invalid product IDs. You only have a few product ID ranges, your puzzle input. that you'll need to check. Okay. Check those ranges. The ID ranges are wrapped here for legibility. They appear in a single long line. Okay, comma-separated list of ranges. Um, first ID separated by last, so they're inclusive ranges. You can find invalid IDs by looking for any ID which is only made of some sequence of digits that repeat twice. So 556464. Okay, if there's any repeats, it's invalid. Okay, so we basically find all of the duplicated strings. This feels pretty straightforward. So val ranges equals an input dot split on a comma dot map, and we parse these. So we have an A to a B, and we're just going to do A dot to int to B dot to int. Okay, let's see if that parses correctly. Split is not a member of list string. Oh wait, we just need next here. Bitlines dot next, because we only have one string. Number format exception. Oh, that is a long. Okay. Too long. Too long. Okay. And then now def valid and long. There might be enough of these that we have to be more clever about finding these than just like filtering through all of them, but we'll see. Okay, we've got all those ranges. So 222, these have to be, so they're going to be like even length. So val s equals n dot to string. If s dot length mod 2 equals 0. And s dot starts with its last half. S dot drop s over 2. S dot length over 2. That's it right there. So we can test that valid. Or wait, this is invalid. Okay, so invalid 11. And let's say 1010. And then 222, 446, 446. Those should all be invalid. Ranges dot. What do you get if you add up all the invalid IDs? So I guess we could just do ranges dot flatten dot count invalid. I don't know if that'll be performant enough, but that will give us the answer. That ran second 687. That seems wrong. Day 2. That seems wrong. Those are all invalid, right? The ranges look right. No. No, no, no. We're gonna filter those and print them all. 687. Oh, no, no, no. We don't count them. We filter and sum them. Filter dot sum. Okay, there it is. So as soon as that loads, that should be correct. It loaded already. Where's my answer? Give me my answer. Oh, okay. No. Okay. 193863444315. Easy peasy. Hmm. Um, there are other patterns. Now, an ID is invalid if it is made only of some sequences and digits repeated at least twice. At least twice. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. Okay. So any kind of repeats. All right, so we have to update our definition of invalid. Um, okay, so let's say val k is s dot length. And now I guess we need all the possible multiples. We don't really need to do math here because they can't ever be all that long. So, um, hmm. So we just take all the ones that are like multiples. Um, 1 to k over 2, I suppose. I think we can just do 1 to k. We're not going to do anything overly fancy. We're going to be not that performant here. We have lots of room. So that filter m such that m k mod m equals 0. So these are all those lengths, and basically it's invalid if there that exists an m such that how do we do this? S dot take m s dot take m times I suppose n divided by m or k divided by m, the length divided by m equals s. Okay. Um, wait, what's wrong here? There's a default definition. Oh yes, right. Comment out this old one. Okay, so those are still invalid. Let's just try this, see if it works. 34421. No need to test it yet. 651192. Hey, there we go. Cool. Not bad tonight. Um, that felt smooth for me. Done in 10 minutes. A lot smoother than last night. I'll tell you that. It hasn't registered me here yet. Yeah, so this is a worksheet. So what I'm using for my editor is Metals, and Metals works. I don't know it works in NeoVim or Emacs or VS Code, but Metals has a worksheet mode. So if you name your file worksheet.sc, then it evaluates everything inline. So kind of like a you know Jupyter notebook or something. It's very handy for this kind of explorative testing, whatnot. Um, let's see where people are. So I was fifth to finish part one. I have finished part two. I don't know why this is not up to date yet. And there were some quick delta times here. But tonight's felt a lot more straightforward than last night. I mean, last night was straightforward in theory. It just had edge cases. All right. I mean, well, with that, I suppose I go back to 2015 and wait for people to trickle in as they finish part one. I'd like to see what other people did, like what their solutions look like. I'm sure there's a nicer way to do this whole bit. For one, this. I think I already have a method somewhere that gets you the factors. Fact, give a math. Um, Alex. Let me see. I'll forget. Well, this is my library code source main Scala AOC. I guess there's libutil. Oh, there's a math. Okay. Math slash package.scala. No, I haven't yet created a factors, but we'll make that to do. Uh, def factors. I think I have it in my project Euler repo. That's too useful not to have around, right? Okay, let's take a look at day 7. Some assembly required. Ooh, we get an assembly problem. Okay, these are fun. These are fun. Um, Maybe I'm gonna hold off on that for just a second. What I want to do is pull up my project Euler code. I don't want to have to like rewrite it. PE. Okay, and here we have our out. I'll do a refactor while other people will finish up tonight's problem. And then we can go to day 7. I don't know why the leaderboards are so slow to update this year. I'm sure more than that are done. Okay, anyway. So here, prime factors. And this version here, Does it need to be just prime factors though? I just want all the proper divisors. Yeah, this is what I want here. And I like this version because it'll work with longs as well as ints, whatever type you give it. So it's generic on this type class here, um, which makes it reusable whether we're doing like big int or whatever. Okay, so proper divisors. So we can take proper divisors of our k and take all of this code here. Proper divisors of n that exists. We'll call it d then. D such that s dot take d times k over d equals s. Um, let's see, aoc.math. We'll just import that at the top. Import aoc.math dot proper divisors. Or yeah, just star. Um, oh, it hasn't been like compiled properly yet, I suppose. Oh, prime factors. Right, we need this function in there as well. Hmm. Okay, I don't really like that I have all that dependency. Maybe I'll save this refactor for later. Make sure my library is stable first. I'll still call it D though because of the divisor. All right. That's our code and we're not touching it anymore. We can move on to day 7. Hmm. Okay. So Santa bought little Bobby tables, a set of wires, and bitwise logic gates. Unfortunately, little Bobby's a little under the recommended age range and he needs help assembling the circuits. Okay, each wire has an identifier and can carry a 16-bit signal. Okay, a signal is provided to each wire by a gate, another wire, or some specific value. Okay, each wire can only get a signal from one source, but can provide its signal to multiple destinations. Okay, and the gate provides no signal until all of its inputs have a signal. Okay, this is pretty standard. It's about what you would expect from the wires and gates. So I'm not too worried yet. The included instruction booklet describes how to connect the parts together. X and Y to Z means to connect X and Y wires to an AND gate, and then connect its output to wire Z. Okay. Bitwise and L shift, left shifted by 2. Not means a bitwise complement. Okay. Okay, so the gates do what we expect them to do. Other possible gates include OR, right shift. Okay. Here's a simple logic circuit. After it's run, these are the signals on the wires. In Little Bobby's kit instruction booklet, provide D as puzzle input. What signal is ultimately provided to wire A? All right. Oh boy. So we have to build this whole circuit and then evaluate it. You've done stuff like this before, but it's always a little bit intimidating when you first start. Um, so we want to model gates. Let me see. Let me switch to a new file. Okay, we've got a day 7 worksheet. All right. So we build a circuit from all of these instructions. I suppose to evaluate, we could say, look at A. These are signals in all the wires. So we could look at a wire like G and see what it's connected to. Y right shift to, and just bubble that all the way down. Um, and let's see, I'm worried if I represent, so I'm hoping that the circuit is like a graph. There's no circle, so I should be able to represent this whole thing in like nested case classes. I think maybe I want a map. Maybe we parse out separately the constants. Yeah, I think for any, I think what we want to do is that for any of these gates on these right side or wires, we want a map from the wire to its expression. So like val wires, there's gonna be a map from a wire, a label, string. Well, for now, let's make a type. So type wire equals just string for now. So a map from wires to gate. It is the output gate. Enum gate. And the gate, we model its inputs. So case and we have A wire and B wire, right? And do the same for all of them. And then define some sort of like eval function, right? So let's just model out like some of this. For A wire, B wire. Um, and we need like an eval function. So say def eval given a wire. So we'll just call it A. And then we want a value int, right? So we basically take, we're given a circuit, which is a map from wire to gate. And we can just recursively evaluate. Um, so we do something like circuit with that wire for A. And depending on the kind of gate, if it's AND, we're going to do recursive eval. So eval. Ooh, I wonder how much this will recurse. I hope not too much. I don't want to have to make a tail recursive. So we have eval. Recursively A, we pass in the same circuits. And we take the bitwise AND. The recursive evaluation of B. Okay. I don't really want to keep passing the circuit around. I'm just gonna make that a given. Using, okay. Okay, eval A bitwise OR eval B. Okay, I think this will work. We just continue to flesh this out. Let's do this map wire.gate map.from. Oh no. You're gonna take the input dot collect. And then we just look at these various cases that we might have in the input. So we have like an A and B goes to C, right? And in that case, we have the C wire going to that gate, and we need to do A and B. And similarly for OR. A and is not a member of string. Oh wait, these are, I mean, these are wires. Wait, I see what's going on. There we go. We need the parens. I don't need to use infix syntax here. So we're given circuit. Given val circuit. Am I doing this right? Wire to gate. Okay, there we go. Now we just continue fleshing this out and we are golden. So we have or and case L shift, and then we have R shift. Case not. Case L shift. It's gonna be eval A. Oh, L shift does take an argument. Um, so it's by some constant. And I'm gonna turn on Copilot here to help me with the boilerplate. Okay, is that everything? There's no XOR or anything? Cool. Alrighty. That looks good. C films, hey, I'm doing all right. How about you? Did you finish having the code for tonight? I got a fun puzzle from 2015 that I'm working on. So we're gonna eval for, what is it, A? And hey, we have an issue. Key not found A. Wait, there's no A in here? Oh, wait, we need to do the constant still. Okay, so case, um, we have a constant to A. Um, Case constant and int. Oh, does it matter? These are 16-bit. I think I should be using shorts instead of int. Let's replace int with short real quick. Oh, right, you've been working on your coding language. Cool, cool. Are you hoping to use it for having to code? Okay, so in this case, we just do a constant of n dot to short. Cool. And of course, we have the label to carry along. Found int and required short. Wait, these all give int? So we have to convert it to short afterwards. Dot to short, I guess. I would have thought a bitwise operator just worked with the shorts too. Um, You've never done admin to code. Oh. Well, it's fun. It's a fun little distraction. And it's a good way to test out a programming language. Lots of people use it to learn a new language. So it might be a fun way to test things out. Match may not be exhaustive, right? Because we have the constant still. And we just return that n. Not a member of int or short. What, you want the two shorts at the end of all of these? A little bit annoying. I'm not sure it's even necessary to. Will like semantics of anything change if we do if we use instances as shorts? I guess the overflow would matter. Well, there's no overflow. There's just there's a shift left and a shift right. That could start mattering. Okay. I guess this thing here makes it. Currently, your coding language is in the REPL stage. That's good. So what does it kind of look like? Math statistics is like inspired by R or something. Number of formats exception for input string LX. Okay, wait, some of these might just be wires to wires. Let's see. LX. Right. For example, LX to A. Okay. So we're gonna do this. N dot too short option. Um that fold. And yeah, in the empty case, we just do wire to wire, I guess. Um, I guess we call it like equal or something. Case equal a wire. So we just do equal. Equal n. Um, Otherwise, we just take the constant. So now we take the equal case, equal a. We just do. Oh, we are shadowing things. I guess we just do eval a then. Unique syntax, huh? Alrighty. Now what's going on here? Key not found 1. One shouldn't be being used as a key. I'm going to separate this into separate cases here. I'll be a little bit more explicit about this. So case A to B, no, I think I'll take my n to A, and we'll add a guard here and say if it's digits, if n dot is numeric, is there a function? N dot for all is digit. Then we have a constant, n dot too short. Or I mean, we could just do n dot too short dot exit is defined. And we can deal with this separately. So in this case, we do equal b. And yeah, we just evaluate on down that line. My stream notifications seem to have stopped. So give me a second. I'm gonna look at that. Maybe I'm gonna trigger a fake test message here. Okay, that's still working. We'll see if it picks up other chats. Ah. Oh, Alex, I think I missed your message. You were asking what problem we're doing. This is day 7 of 2015. Okay. Got non-empty. Oh, too short option. And I guess in this case we have a constant. Found a gate. Required a string and a gate? How did that happen? Oh, right. Yes, we always have A. So A goes to that. And here we have A goes to equal B. Okay. Key not found A. Interesting. So we're still kind of misparsing these. So what would happen to the A? It should end up A points to B, right? So like wait, A should point to LX. So let's not eval this right yet. Let's make sure we have everything here. So let's do just a circuit for each print line and see what this looks like. A should go to LX, so A should show up here. And then A becomes a key in the map pointing to LX. HY goes to L shift. Sure, sure, sure. Um, somewhere in here, there's a. Can we see constants? So there's B to 14146. That looks good. Can we see any equals? LX equals A. Okay. Um, oh, right. We had this backwards. So it should be our B, actually. Because B is like what's going out in the output. So B equals A, right? The thing on the right side. B equals A. There we go. Okay, I think that should fix that. I see Black Beat. It started 10 minutes late today. Oh no. Um, where did you finish though? I imagine you still made good time. Um, I'll check the leaderboard. 10-minute delta. Oh, you started more than 10 minutes late. That's too bad. What were you busy doing? And how did I do? So people have come in now. I was fifth on the first one and fourth on the second one. Fourth overall. Okay. I feel better about today than I do about yesterday. Your coding language variable idea. Oh, yeah, I missed that. So you were saying the new coding language will be gradually typed. All string variables start with a dollar sign. All number variables start with a pound sign, and all arrays start with an at sign. Huh. So the type determines the variable name. So, or like the variable name includes a type. That's interesting because people kind of do, like if you're in a dynamic language, people kind of sometimes do that. Like in Python, people might write the name into the type or the type into the name anyway. So that just makes it kind of more formal. Um, that's interesting. I don't know like in what domains. I know like say in APL, you can be like very specific on like you care a lot about like a small number of like very specialized types. Maybe in that case, it's something similar. If you're just doing like mathematical analysis, it makes a lot of sense. Missing any Monday bargains? Oh, you mean Cyber Monday? Cyber Monday lasts all month. Oh, this hasn't printed yet. Key not found one. Okay, how's a key one getting into here? So at some point, the only things that are keys should be like on the right side here. So is there an arrow pointing to? It must be when I have like an equal. I'm doing an eval because I don't think we ever point to a number, right? So no, we always point to letters. So something's happening in my eval here. Oh no, your Visual Studio crapped out. Oh no, time to switch to VS Code. That's scrappy, very scrappy to do it in the command line. Well done. You overcame adversity to make it here. Um, oh, I think sometimes B might be a constant. These aren't necessarily names. These aren't necessarily wires, are they? Let's look at ands. Is ever and a number? Oh, like here. 1 and CC. I see. That's what I missed. 1 and. Hmm. Okay, so I have to parse whether these are constants or not. So I don't know that this is a wire. I need like a function that will just parse that as a wire or a constant. How does the leaderboard work in Advent of Code? Um, well, let me pull that up. So basically here, like on this leaderboard, for example, there are, I don't know how many people. There are 42 people. So when you get the first star, if you're the first one to get it, you get 42 points. The next person gets 43, onward down. And then for the second star, the same thing happens. So first person to get the second star will get the 42 points, the full 42 points, all the way down to the bottom. So you can do really poorly on the first part, but if you're still the first to finish the second part, you can still get the full 42 stars for that second part. And then this is just a running total sum. I'm currently in 6, and I'm not like I know Alexander's really fast. Rascal 2, I think we could be neck and neck sometimes. So I think I have a chance of getting past Rascal 2. But I'm not too worried about being competitive. Okay, so parsing this, these are not necessarily all wires. Hmm. I don't want to do like this code everywhere, so I'm going to put that into some sort of function. Um, let's do a method here. Def, we'll just call it arg. So there is some string, and this will be, oh, okay. And now I need to take a wire or a constant. I need to rethink my model. I wasn't thinking it properly from the start. See, I could have this whole kind of nested circuit thing where, this is gate is basically an expression, and the A side could be another and, right? Like if it's not a constant, then we just do the next AND gate. But I think we'll struggle to build things in order because things are referenced before they're defined, right? So dy here is referenced in EB, and then, it's defined much later on, dw or dx. Um, I could do a union type between a wire and a constant. But then now when we do the eval, hmm, we can have an eval function that handles wire or constant. I'm not sure I like that. Man, I really wrote myself into a corner here. This should be something I'm able to like just hammer out. Okay, maybe we'll make that a union type. So if it's a wire, we go into the circuit. Eval wire or constant. Okay, a match. Um, and if it's a constant, we just go into n. Otherwise, if it's a wire, then circuit on that wire and match. Um, and now this returns a wire or constant. I don't think this is pretty, but it's gonna have to work. Oh, we're on TV. Welcome, welcome. It's been a year. I don't think I've seen you since last year. How did your day two go? I assume you're done by now? Um, hmm, hmm, hmm. So we're gonna do basically an s.to short option match. And if there's some value, we're gonna wrap in a constant. We'll just do n. Otherwise, this is a wire, and we just do s. And now we replace all of this with that. Ditto with a knot here. And interestingly, we do the same thing here. I think equal, we can, I want to rename that to like ref or something. Ref will always be to another wire. Okay. So that is fine. And yeah, now we have a way to eval those constants properly. Let's see what it gives us. An error? Required? Oh, wait. Yeah, we need to change the types here. Um, wire or constant. Whoops. Wire with wire or constant. Okay, this will be worthy of a refactor later. Equal. Equal can just be wire. Doesn't need to be or constant. Are there still issues here? No, no, no. So that should just be running. That's evaluating. That's evaluating for too long. Oh, that seems like a loop. Hmm. Okay. Well, debugging that's not going to be all that fun, will it? I mean, maybe we can do like we can make some example circuits and do evals on various values there. We can see if the same thing happens with this example. So let's try that. But I worry. Oh, L shift. L shift, this could be a reference to. So we need to change that. L shift and R shift, those need to be parsed as args. Okay, whether or not I complete this tonight, I do want to like revisit this and make this clean because this has potential to be like super clean. Let's just give that a try real quick. That definitely was a fix that needed to happen. I don't know if it'll fix our particular issue. Um, but what kind of infinite loop might we have introduced? So let's say this is a wire equal A. So we evaluate. Um, that's fine, right? Let's say eval A um, is a constant. Then we notice it's a constant right away, and we just return n. So that should be fine. But if we notice it's a wire, then we look at the circuit and look at what it's connected to. I hope the circuit itself isn't like a full loop. It's not gonna have loops in it, is it? I mean, I know circuits can have loops and still be stable, but that'd be cruel to have that be the case here. Okay, let's print what we're evaluating and see what our loop is. So print line evaluating A. So let that time out and see what it gives us. And in the meantime, let's make an example. So day 07, 2015. Example file. And we can test around with this. And we'll have a much easier time debugging that. Oh wait, there's no output. There's no print line output when it's times out like that. Okay, well cancel that. We're just gonna debug with the example. Okay. We can do a circuit for each print line and see what we have. Hmm. Does this look like the example code highlighted on the right? Um, So we have E is X or Y. Okay. We have X is constant 1, 2, 3. Y is constant 4, 5, 6. Cool. F is a constant, wait, F, L shift X by 2. G is R shift Y by 2. I is not Y. H is not X. D is X and Y. Okay, that all looks correct. Let's do an eval on one of these and see if it goes infinite loop. Let's eval X. That should just give 1, 2, 3. Real straightforward. It's slow to show me. Okay, yeah, 1, 2, 3. Just do all of them. So let's eval E, eval something that uses D. What uses D? I don't know. Let's do F. Okay, it is complete. Let's see what we get. I should just do all of these, honestly. 72, 492. Yeah, those are all correct. Okay. So my eval function works with the small circuits, but we go into an infinite loop with the large circuit. Oh, it's short and unsigned. I don't think that should matter. Like, it's still the same bits, right? Maybe we should use int. Let's just try that real quick. So, short turns into int 14. Then we don't have to worry about like the sign. 16 bits fits into the positive to 32 bit. But I do wonder about the overflow. These worksheets, they evaluate very quickly. Oh, we still have negative 124. So maybe H and I are just incorrect. So this is a not. Oh, maybe I'm not using the right definition of not. The bitwise complement for the value. So it just flips every bit, right? And that's what this does. So let's say, I don't know, 234.2 binary string. And then, if we took the complement, that should be 000100101. Yeah. But now in this case, if you do take a complement and then like shift right, Well, let's see. Should the right shift fill in with it's gonna fill in the sign, which is good, right? Okay. Well, I'm not too oh, it hasn't even updated yet. 2 plus 2. So regardless, like I don't think that issue is what's causing my loop. Um, so I don't think I need to get caught up on like ins versus shorts right now. Um, I need to worry more about why it's an infinite loop. Maybe this is a problem I sleep on, huh? And we just raid someone else because I want to do this problem with proper justice. um, let's go back to today's problem. So, anyone have any like clever one-liner solutions they were happy with for today? There's not too much to talk about this one, but I'd be happy to see other people's solutions if they have them up. And in the meantime, let's start looking for someone to raid. We can finish day 7 tomorrow, and we'll make it nice. That can be our warm-up tomorrow. It'll be satisfying to get that. Pure brute force, yep. It ran in 5 seconds. It reminded me of the cube lights problem from 2021, so I thought like we had to be smart about ranges or something. But nope. Nope, this was fine. I know. So I take it you took the time to make it nicer. Alka's online. Um, Bad Cops online. I haven't seen Alka in a while. We should say hi to Alka. I mean, Alka was just in here earlier today, but I like Alka streams. Yeah, you know what? In the process of this, I lost my part 1. Um, I should have kept like the old definition. But yeah, total pure brute force is pretty easy to write. What optimization did you use, I see? Because I'd be interested to see, took the first half of the string, new string by doubling it, yeah. Um, and incrementing the half. Special handling for when the number of digits change. I see. So you computed the invalid strings. Oh wait, I was mixing this up with another problem for a second. Day 6 of 2015 I also did with brute force. And that just worked. So this is like a bunch of ranges, areas in the grid. You either like flip all the lights on or off, or toggle them. And I just simulated the whole thing. I didn't have to be clever about areas or everything. I could simulate just every single point and it worked fine. It was a fun little problem. But you knew that. You saw it earlier. Yeah, it's true. Brute force for day 2. Um, for the 12-day year, I'd like it not to be brute force. I was hoping for a problem that'd be like longer than 10 minutes for today. But good thing we have past years. Uh, 2015 problems have been fun so far. So even back then, Eric had an edge. Wrote fun puzzles. I have been enjoying the day 6 and 7 problems that I've been working on today. So I think I'll enjoy finishing the rest of 2015. Seems like a good year. All right. Well, let's raid Alka. I imagine Alka's also finished with Avena code. Maybe, maybe not. Maybe we just see if someone's still doing Avena code. Um, we'll just send it. We like him. Okay, wait. I want to see your code. So here's Icy Black Deep's code. Um, basically, what'd you do? Okay, so you grab the first half substring. Um, if val is greater than s, and so it fits within that range, then ans plus equals to val. Okay. That's not too bad. That's easier than I thought it'd be. Michael's still working on it? Okay, let's raid Michael. Yeah, Alka's been finished for a while, I imagine. Yeah, you definitely didn't need to try. Brute force worked today. All right. Let's raid Michael PC Gamer and see how he's doing. Oh, Temporalis isn't there. All right. Well, thanks everyone for stopping by. Um, see you around the rest of the month.